Welcome panelists to this session. Thank you very much for sparing time, and we look forward to your session. We'll start with an address by Ms. Pamela Kumar, Director General TSDSI. She will give us an overview of the work being done at TSDSI and our role in driving India appropriate requirements and IP in global standards. Over to you, Pamela.
Thank you, Bindu. And first of all, it's really exciting to see this session rolling off. We have more than 160 attendees, I think this paradigm shift that we want to make towards standards-driven research and innovation in our academia, the ground has been very appropriately set by Professor Rajat Moona and Kishore Babu. So, you can see the impetus, and that's what I would like to, emphasize in my talk here. So I'll just share my screen and bring my presentation and then proceed with the session. So what I would like to say is that, life around us is changing, right? And how this team here, all of us who have come together for this session, how can we lead this change using standards-driven research? So that's what I would like to address. And as I said, again, Professor Rajat Moona and Kishore Babu have set a very good context. So I will breeze through the initial conceptual work and focus more on what's happening in TSDSI. So what do we need to lead, right? What is changing? What is technology disrupting? Let's step back and think about it. So life, the way we know it, is changing. And here is this Atmanirbhar Bharat slide that I picked up. And look at it, the economy, the infrastructure, demography, and demand. These are the pillars. And right in the middle there is that all of this is going to be technology driven. And we are actually experiencing the role of technology right now. So look at the other thing here, that this requires bold reforms. And I could see Kishore Babu, his presentation was really bullish, and looks like he's getting a lot more traction and attention in the corridors of the government now. So this is going to make things a lot simpler for us. Now let's look at it from a technology standpoint. And I think Professor Rajat Moona put it very aptly, that compute is communication and communication is compute. So the boundaries between the different so-called verticals of technology have actually converged. They have all become building blocks in creating solutions. So these are the building blocks, whether it's the core semiconductors or system technologies, communication, computing systems, then all the web technology, data technology, cloud, social media. So all of this is really coming together and getting focused towards vertical industries. And the very way in which we are developing technology and innovating is changing with this so-called open model. So it's open innovation, open standards, open source, and technology is making it possible for us to all come together on these collaborative platforms without the encumbrances of very rigid organization structures. So this is exciting times. Now, what are these applications of technology? And here are a few. Look at the architect here. Architect does not do blueprints anymore. He just builds these video models, and then the model gets transferred to a 3D printing machine, which can actually build your construction. Right? Look at surgery being done remotely. Vehicles, intelligent vehicles, avoiding collision, cooperating with each other, unbeknown to the people sitting in the car. You may not need a driver very soon. And robots collaborating on the factory floor, and drones are everywhere. I mean, they're showing this Amazon drone delivering packages, but drones in agriculture, and you name it, and drones are coming everywhere. So there are different ways to live, work, and play, and even go to war, right? They're talking about smart warfare, joint warfare. So here it is, health tech. Health tech means zero touch. So zero touch, there are robots in our hospitals today taking, feeding the COVID patients and giving them their medicines so that the healthcare workers can be protected. There's we talk about finance and education happening from home. We are all experiencing that, agriculture is moving towards high value agriculture using technology, with social distancing, contract tracing. Technology is playing a big role in our cities and villages. And that in the industry today, they are saying that only 25% of the workforce can come to work. So industry needs to leverage technology in a big way. So life is indeed changing, and technology has a big role to play. So now let's step back and see, Kishore Babu and Rajat Muna both talked about the telecom revolution that has happened in this country, and I have a few slides on that. So what was the phase one? And I think Kishore Babu gave a very good analogy of the times when you used to do a trunk call, right? And nobody had phones. Then came the time, there were a few 100,000 new line land connections happening every year because we were exporting infrastructure, and it was very expensive. So you did one call every month. Mute on. I think people need to go on mute, please. Okay, then Pdot made its the landline exchanges, and we brought down the cost of the infrastructure, and we started having these so-called STD booths, which were probably better than doing those old trunk calls. But you could walk down to a booth and make a phone call, and then lo and behold, mobile happened, right? And the cost of $18 from $12. So now let's look at the more recent revolution in 2G, 3G, 4G. So as you can see, I call this the lying down hockey stick. So we make an announcement, we are going to embrace this new technology, we start struggling with it, and then it takes a while, and then exponentially the acceptance. So in 2008, suddenly 300 million lines going to 800 million lines happened in 2G, and then 4G, 3G was introduced, and we were plodding along, figuring out how to bring broadband in wireless. And then 4G was introduced, and suddenly there was a big pickup to 400 million connections in 4G within a year. So what does it mean? It means there's a huge latent demand for technology, and we embrace technology. Our villages, our people in all walks of life are embracing. There are no barriers to embracing technology, but we need to deliver it in a form and in a way which meets their requirements. We need to understand. We need to build our own use cases, and that's why it becomes important that we participate in the development of standards, because standards are driving the development of technology. Standards today are defining 2030 technology. So unless we are in there, taking the Indian requirement and driving innovations and taking our research to the standards bodies, this lying down hockey stick is what we want to make it a standing up hockey stick in 5G. And that is where research has a big role to play. So another important thing to understand is that in this era of 5G and beyond, it is not just a leap. So you see this triangle, it's no longer a linear progression in the feed, in the line, the speed of communication and the density and, reach, what do you call it, the capacity and the intersite distance, right? It's not linear anymore. It's a triangle now. So when you are building smart city solutions with IoTs, it's more about density. The speed may be lesser. When you're talking about enhanced mobile broadband, the emphasis is on 100 megabit per second. The emphasis in machine type is on 1 million devices per square kilometer. And then ultra reliable is talking about 1 millisecond latency and maybe 5.9, 6.9 kind of reliability. Now, if you want to give all these three parameters to every application, it's going to be phenomenally expensive and not really needed. So for each application, you need to engineer it on the right point in this triangle. What are you going to optimize? Is latency more important? Is speed more important? Is density more important? What is it that, and for each application type, you need to optimize and build solutions appropriately. So it's not only about the building blocks of technology, it's also about the parameters and the standards or the requirements for each type of application. And here are some examples. So what needs to change? So there has to be a paradigm shift if we need to do this right from an India perspective. So in India, so far, we've always been in this acquisition mode, right? So whereas research has always been about concepts, looking at deep niche areas and developing new algorithms or whatever. Okay, not really thinking about the big picture of how technology is going to be implemented and where are the problems in the deployments, and then doing research on it. They're not hands-on. But our acquisition of technology, we've always been acquisition focused. We start with RFPs and tenders. We assume that technology developed for other parts of the world can just be acquired by us and put here, and it will work. And the lying down hockey stick model has shown that that's not what happens. We need to engage in the very beginning, when we need to define India specific use cases. We need to get involved in the demos of technology to understand the potential of technology, translate that into requirements, get involved in proof of concepts, test those proof of concepts in our conditions. And this requires lot more emphasis on and investments in trials, in interops, in pilots, and standards development, which we don't do. So coming together, industry, academia, and government, hardening of the to get involved in the hardening of technology before we get into acquisition is the paradigm shift that needs to happen. And this will influence the direction of technology. So we need a framework for this to bring all of them together, and TSDSI provides such a platform, okay, which will enable us to embrace new technology, which is more effective from an India perspective, and brings our academia, government, industry, and startups together. This will enable us to influence the direction of technology. It will enable us to make a generational leapfrog, and hence improve the take us leapfrog to a new socio-economic way of living in this country using technology. So what's the role of TSDSI? And I think the previous slide said it. And again, I say that bringing government, industry, academia, startups, and the user community on a collaboration platform, which is open, which is, everybody can come and join us. And we have a role to play. Government has been reaching out, and there are a lot of initiatives we've been driving for DOT. Sorry about that. We are a member at ITU along with DOT and TEC. We have been going there. We are a partner at 3GPP and 1M2m. We have partnership agreements with all these other bodies: IEEE, GCF, 5GIA, Broadband India Forum, CCICI, ATSC, TICE, etc. We also are running various projects like Indo-U project along with ETSI. We collaborate with IF3, COAI. So we have created this whole framework for everybody. Now, what we need to understand is that standards business is not an easy business. This is high risk and high. I call it like the Sagar Manthan. It is the Sagar Manthan of knowledge, right? And out of it comes this pot of Amrit, which we call the standards document, right? So the Sur Asur Dana, the industry, corporates, the academia, and everybody needs to come together, engage in this manthan, and then only we can create a standard. And it takes time, it takes a lot of investment, so it needs resilience, and it is hard work. It's like churning the ocean. So this is the membership of TSDSI. We have, we have had these 8 categories into which we distribute our membership, what we call our vertical categories. Recently, we have done some modifications, and now we are moving to a model where we are going to have 11 categories instead of 8. We have split the vast telecom software into 2 different categories in 9. So the motivating thing, so we can see that there are lot of players in this. So we have brought out the semiconductor part away from the software part in this. We have introduced another category on service providers. Besides telecom service providers, we have other service providers, because it's becoming to reflect the convergence that is happening between telecom and the TSPs and ISPs coming together. So we have other service providers, and also the vertical driven service providers. So this is the change happening, and you need to come and participate in this. So what is the journey that we have had? So as I said, this is hard work and it takes time. So TSDSI was registered in 2014 with 39 members. I think the founding group was about 11 members before that. And we have grown to come to, 65 plus members now. The work, initial part was just getting our rules and regulations in place and understanding how to work as an SDO. And it's only in 2017 and 2018 that we really started doing standards and having standards on our website, standards documents, a lot of them from transpositions and some of them done internally, like the CIPRI front hall. And now we are beginning to have the impact in the global forums. So TSDSI did what we call the LMLC requirement at ITU, and I'm sure Mr. Mittal will talk about this. Then in 3GPP, we've the NAVIC standard from ISRO, based on the ISRO constellation, has now become a work item in 3GPP release 16. So, you know, 1M2m, which we have been participating in, we have taken it to DOT to consider it as a national standard. TSDSI has been called by 3GPP to oversee the contributions from developing country proposals in release 17 and bring it to the coordination group and inform them if we are facing any difficulties, which we have been facing. So you can see that a lot more interesting work is happening. Here is the detail of our study groups. We have a study group of networks and study group services and solutions. Here are some of the topics that are being discussed, and I'm sure a lot of you are actually doing research in related topics. Then we also have a roadmap committee where when you have an idea, so in the standards there is a well-defined process to bring it to a study group. We call it a NIP. You need 4 other organizations supporting you, so there is a lot more regimentation in coming to an SG. But we have also a roadmap committee where when you just have an idea and you don't know how to go about it, you need to bring it to the roadmap committee. We have further enhanced this with the concept of discussion groups, where even at a more earlier stage, people are coming together in discussion groups and formulating their concepts, then bringing it either to roadmap or to study group, and then carry it forward. So a lot of ideas come, and then out of that, the crystallized ideas go into our study groups for deliberation into standards or global contributions. This is a leftover slide. What happened? Okay, so so to summarize, there are a lot of pre-standardization activities as well as standardization activities that our members get involved in. It's all kinds of consultations from the government, use case labs, white papers. We conduct all kinds of workshops on specific topics that are brought by our men, and these workshops are now becoming discussion groups. We are involved in all kinds of global collaborations and, of course, conferences, trade shows, etc. And standardization activity is, coming to our roadmap committee, coming to our study group, working groups, and collaborating and participating in the international SDOs. But I think to conclude, what I would say that you need to look at this cycle of standards-driven research and research-driven standards, right? So at the time when you are defining your PhD thesis, you are finding the problem statement. If you go and attend the standards bodies, the standards, the work happening in the global standards, where they are thinking about the future of technology, that will give you a lot of interesting ideas to incorporate into your research. When your research is taking some shape and you are innovating, you should be thinking about maybe some papers or some publications. You also need to think about what can be contributed to standards based on this work. And I would encourage the academia to think about giving credit in terms of the promotions or your whatever process that you have in terms of performance. Publications are, I think a standard should be equal to 10 or if not 100 publications, a contribution to a standard, because it takes that kind of effort to make a successful contribution to a standard. And I would really encourage you to think through that. So thanks a lot. As I said, standards is about collaboration. It's about consensus building, and it's a lot of fun in an open forum where you get to meet all kinds of serious technical people talking serious technique. It's not like going to conferences and trade shows where a lot of stuff is just fluff. What happens in standards is, as I said, the Sagar Manthan, the nichode of all the knowledge that people bring to standards. It's a serious technical discussion. So looking forward to all of you joining us and participating in this.
Okay. Thank you very much, Pamela, for that very comprehensive overview establishing the premise of standards bodies, the opportunities and the work being done by TSDSI and our footprint. I think that's laid a very good foundation for the rest of the deliberations in the workshop. I would now, Pamela had mentioned about 1M, 2M, ITU and 3GPP. So the next presentation, the next talk is from Mr. Arindam Bhattacharya from CDOT, who will be talking to us about 1M, 2M. And so over to Arindam. And may I also request the speakers to please try to limit your presentations to about around 10 minutes, 10 to 15 minutes, so that we can make up for lost time and have more time for interactions. Thank you. Over to you.
Yeah, thanks, Bindu. Thanks a lot. Uh, at the outset, I must express my gratitude to the organization, TSJSI and IIT Bhilai and the other organizers who have kind of invited me to speak in this occasion. And welcome all the participants. I hope you will have a fruitful time here in this workshop. Thank you. With that, I start my presentation. I'll try to stick to my time. Uh, just pardon me if I go slightly overboard. I'll keep a tap on the time. Thank you. So I'll straight away move to my presentation. I'm going to talk about 1M, 2M. So a bit of 1M, 2M. 1M, 2M is a very vast subject, but I'll try to do justice to that. So it will be 1M, 2M overview and positioning. I am Arindam Bhattacharya, a group leader in CDOT, looking after the M2m Iot initiative, apart from other areas which I kind of undertake. Now a brief slide, some statistics, but why is it important is firstly, just see where we are today. We are at 2020, wherein we perhaps would have experienced, because this is a kind of market research published by Growth Enabler, and this report stated that the market will grow to $457 billion by 2020. So a CAGR of 28.5%, which is phenomenal. And if you see the use cases or sectors in which IoT is being used, so this is what I'm talking about. So as you can see, there's a growth enabler report which stated that the market will grow to 457 billion by 2020. It was done in, I believe, 2017, the prediction. And it's been true to the prediction pretty closely. Had it not been COVID, it would have been even more so. But even with COVID, as you can see, IoT has not kind of stopped. Majority of the applications that have come to aid of this kind of a pandemic has been IoT driven. Now, the surge of connected things that was predicted by machine learning research, that was also close to the same figures that Growth Enabler stated, that is around 25 billion interconnected devices by 2020. And perhaps we are very close to that now. Now, when I talk about standards, people talk about a lot of things. They talk about protocols being standard. They talk about, particular technology being standards. So it's a jungle, really. You see BACnet, the Bluetooth being talked about as standards, which are de facto standard. Then there are standard organizations like IETF and Industrial Internet Consortium and ISO-IEC and ITU, along with 3GPP, the big names all over there. And there are those who are playing their roles in the IoT segment like IoTVT, right? DDS also being there. So, and OPCUA, the Industrial Internet Standardization Body, so that also is there. So we need to figure out which technologies will be used in M2M or industrial IoT, or for that matter, any segment of IoT, and which technologies are overlapping or complementing each other. So we have to, do a proper understand. We have to make a proper understanding of which standards apply where. and what is the standard which actually binds them together in a common thread. So I'll be more clear later when I talk about 1M2M in detail. If you talk about IoT applications today, you will find majority of the verticals or sectors which are using IoT have, I mean, they kind of develop the entire technology stack from bottom to up. That is, for a supply chain or industrial IoT, they will put up the sensors to or whatever information they gather at the backend system, they will cover everything. So the standards confined to them, and in many cases, they develop their standards within themselves. Now, same applies to utilities, that is the smart metering or whether it is gas, energy, or whatever. Then healthcare, fitness, smart cities, automotive, connected car, or connected home. In every domain, you will find they have defined certain standards regarding their data models and the technologies that they used. And in turn, what they have created? They have created silos. So silos would mean that no interoperability, no sharing of data, and there is no common thread which binds them all together. Now, if they don't do it, so what will happen? There will be a huge cost. The total cost of ownership will become high, and major thing is that data sharing, which is a very important part of an IoT ecosystem, that doesn't come in as easily as it would have been in a if this was thought in an altogether different way. And what is that different way? Look at this. All these verticals being there, had there been standardization in connectivity, IoT service enablement function, IoT application, data storage, data analytics, and data representation or data presentation across the verticals, it would have been a much simpler way which answers and addresses all those issues. So a global interoperable standard which was required or which is required that enables a cross-vertical IoT ecosystem. Now let's go a little away from this, talk about what is meant by a M2M service layer and why we are talking about M2M service layer. This M2M service layer is basically the foundation of one M2M, that is the horizontal middleware platform. Take an example, let me take an example of a HVAC system. HVAC means heating, ventilation, air conditioning system. Now, in an HVAC system, there will be some temperature sensors, there will be some flow meters, there will be certain valves and pumps, and some controllers which are represented as IOs. There will be a heating element, and there's an air conditioning system. All these are connected to some kind of a communication device locally, which communicate to the service provider's communication infrastructure, and that is connected to a data center or a cloud infrastructure, right? And at the back end, there will be that analytics or monitoring application which actually monitors all of them and controls it. It can be proximal, it can be distal as well. Now, come to think of it, what happens in an HVAC system? The temperature sensor sends a temperature reading. The temperature reading from that controller goes to the communication device, which is then transmitted to the service provider's network and to the data center. So what we are talking about is the flow of information from the sensor to the data center. And what happens? An action is taken. So the action is, and if the temperature is high, the pump needs to be turned on. Now, pump needs to be turned on is an actuation information that goes from the data center back to it as a machine ordering or communicating to another machine. And what was kind of used from a networking standpoint in this whole flow of information is a LAN locally, then a wireless WAN, and then a WAN, and that's it. And on top of it, what communicated through these networking elements? The applications. The applications which was responsible. A transducer is a mere transducer. So a controller system which actually is interfacing with all these elements is an application. The intelligence lies there. So application through a LAN communicates through a communication device to a service provider, and there is an application which is sitting on the data center and an application which is sitting above, which is making sense of the information that is processed by the infrastructure at the data center. So if I simplify the diagram, it is like that. And what is needed at these 2 points are the middleware. The middleware communicates to the middleware to make a sense. Now, if I simply dissolve what is there at the back end, what you actually need are applications talking to applications through a middleware platform. So underneath that is communication network. Forget what communication network there would be. An app scenario like this would need applications through a middleware platform, talk to the applications having another middleware platform. Now, the functional architecture becomes something like this. Now, go ahead, talk about an e-health scenario. Your connected health bands, they talk through your mobile, and that talks to the cloud. Same thing, applications through a middleware platform talking to another middleware platform at the infrastructure node. So these two middleware platforms, one is in the field domain, the other one is at the infrastructure domain. But the scenario is same. So for eHealth also, the architecture is same. Same applies to any application that you pick up, whether it is connected home, whether it is automotive, be it metering, be it industrial production. So what it is an application layer, a service layer, and a network layer. So all applications talking through a common service middleware service layer and at the infrastructure domain and at the field domain. And communication networks provide the communication facility to it. So a middleware platform and an application which is agnostic to a communication platform, and that is what is needed in all kinds of IoT applications. This understanding gave way to the siloed ecosystem, which is from a very vertical centric siloed IoT implementation to a common service platform based converged ICT infrastructure based M2m devices and applications on top of it. What changed in this is that now there will be a lot of interoperability at the level of communications and data and seamless interaction between divergent applications and devices. So the applications on top of the common service platform need not know the nitty-gritties of the network or the devices being connected over there. Come to think of it, a sensor is a sensor. What type of sensor it is, that if the application is able to give that information, that application which is sitting close to that particular sensor, the backend system really does not need details about that. Now, a common service platform, if it can give me that information in a seamless manner, so I can simply make that kind of non-visible to the backend system, or the backend system become oblivious of the nature of the sensor being there. Now, when I talk about that, here comes the importance of 1M2M. So 1M2M is a partnership program of 8 SDOs across the globe. So the 8 SDOs being Itr, TIA, Etsy, CCSA, TTA, Arab, TTC, and our very own TSDSI. And it also works with many other standard bodies. So how it works? So they are all, these SDOs are all partner type 1, and they are all major SDOs around the globe. So the members, that is companies, they are around 240 members who participate in 1M2M via admitting partner type 1. And the IPR policies and other things are these partner type 1 organization is binding for its members. And then partner type 2 are there, who are the other fora, standardization fora around the, or associations or consortia, across the globe, who participate and contribute in 1M2M with compatible IPR regime. And it was created in 2012, and currently we are working on release 4 and release 5. I will talk about that. It conducts interop events, it conducts technical plenaries, and through that, the member organizations, they participate into these technical plenaries and technical meetings and contribute to standard. Just for information, CDOT has around 321 technical contributions to this global standard, which is M2m. Now, how it works, the process is various sectors like energy, enterprise, healthcare, public services, residential, and other, they feed in to requirements. That requirements are captured in a technical specification called TS0002. Through those requirements, the technical reports are generated and the technical specs are generated. Now, those technical specs actually are used by the developer and the test events to test the implementations. The implementations actually feed into the test events, and through that, it goes back to the technical specs for further modification. And the certifying body actually does the certification based on the technical specs and the test methods that are created along with the specifications. Now, the standard for M2m Iot is something like that, where different verticals, you name it, and they are there: energy, home, assets, manufacturing, anything. So simple APIs and standardized interfaces are exposed through this service layer, and these applications, these verticals actually are the applications which access the service layer through those APIs, and the service layer processes the data. So everything is a kind of resource over here. So making use of the transport protocols and the communication hardware, it actually provides a very standardized interface and information model to these applications. So what is it? It is a standard for middleware platform. It sits between applications, processing, and communication hardware. It's on sensors, actuators, gateways, clouds. Authentication, authorization, encryption is provided through this, and connects the producers and consumers securely. And what is important is that it hides the complexity of network usage from applications. The application need not know. So there are many functions. So what we normally call a common service layer as, that is basically a kind of amalgamation, or a kind of a combination of all these common service functions. So these are the common service functions like registration, discovery, security, group management. These 14 common service functions are what that make the common service layer. So this, you can assume it or consider it as a toolbox which is utilized by the application, and those applications actually use these protocols, which are the protocols that are allowed by various devices, sensors, and which are there in the cloud, applications in the cloud or in the host side field domain, to access the common service layer or the common service layer platform using these protocols, and generate information and consume information and make sense and analyze and create intelligence out of it. Now, when we talk about collaborations, we've shown different industrial consortiums and fora. So there are various which are being used. You saw the initial slide where we talked about various standards. M2m collaborates with different bodies like OMA, DM, OMA, lightweight M2m for device management. It interacts with that. It enables that and is a member of that. Now, for constrained devices, we make use of CoAP and MQTT and WebSocket. So these are the bindings that are allowed or provided as part of M2m specifications. Then 3GPP machine type communication and W3C WOT Web of Things, they provide the semantics and the interworking respectively. So you have various verticals on the right hand side, where industry vertical, home, e-health vertical, and their different standardization bodies like IICA, IOTI, they all provide the reference architecture and test bed, and they interwork with one M2m very seamlessly. So any kind of standard that were created in a different vertical segment while they were using it in a very siloed manner have been utilized in this 1M2M ecosystem or 1M2M standard, so that those standards do not go waste. If some vertical has defined certain data model, that data model is getting used in 1M2M and still providing that interoperability and other features of 1M2M, which actually provide for a horizontal framework that are seamlessly integrated using 1M2M. So the architecture or topology of 1M2M is using certain nodes, which are the application dedicated node, middle node, and infrastructure node. The application dedicated node, the application service node, and the middle node are the field domain devices, and the infrastructure node is the infrastructure domain, which is at a data center or at a cloud. So the application, whether it is a host-side application or a head-end application, both are treated in the same way as application entity. And every as IoT information or IoT ecosystem in this is treated as a resource. So resource is a state information, and resource are the entities which actually provide the state information, and they are contained within all the common services. If you see carefully, the common service entity or the common services are available both at the field domain and at the infrastructure domain. If you recall the HVAC example I had shown, the common service element in the field domain, that is at the premise where the HVAC system is installed, and also at the infrastructure domain. Now, when you talk about the various releases, as I mentioned to you, 3 releases have already been published, and we are currently working on release 4 and release 5. Release 4 is due next year. So the initial release 1 was basic features and functionalities. So all those common functions were kind of defined in release 1. Release 2 brought in additional features like time series data and flex containers and semantic descriptors, and then from security for dynamic authorization and end-to-end security. WebSocket was introduced in release 2. Before that, it was only HTTP COAP and MQTT bindings. Another binding came in. Then ontologies for home automation, home area information model HAME, that was introduced in release 2. Then app ID registry was introduced in release 2. Release 3 brought in 3GPP SCF interworking. Till release 2, only IP kind of data delivery was permitted. With release 3 came in the control planes, service capability, exposure function, non-IP data delivery, and UE reachability monitoring features, along with other features. So from 12 common service functions which are available till release 2, it became 14 common service functions. So as you can see, things are dynamic, things are moving. It is not static, and it is getting mature day by day. So release 4 brings in more features, wherein in 3GPP interworking, a lot of interworking now comes in, because the basic features have all been done. Now there are advanced features where we are bringing in fog, edge computing, service provisioning, and service pooling, etc. We are talking about more ingrained 3GPP and interworking, vehicular-centric features, semantic reasoning and ontology mapping, and so on and so forth. And as you can see, based on this, there have been various implementation, both open source as well as commercial. You can find CDOT's name being there in the commercial implementation. At the bottom segment, the very top left, along with very other, luminaries in the field of telecom as well as the IT domain. The names like Hewlett Packard, NEC, along with Interdigital and LG, all being there. So they are all members of 1M2M. So these are the links and contacts for 1M2M. It's an open standard, so anybody can go, and you can also access it through TSDSI, because TSDSI had transposed release 2. of the specifications, and the release 3 is under consideration. Thank you. I believe I stuck to my time. Any questions?
Thank you. Thank you very much, Arindam ji. And in the interest of time, I request and that we take up questions at the end, towards the end of the next session. But thank you very much for giving a very comprehensive view of 1M, 2M, why 1M, 2M, and what are the features and how we can contribute. Thank you. We will now invite Mr. A.K. Mittal, who's our advisor at TSDSI on networks, and he's also previously he's retired from Telecom Engineering Center as senior DDG, and he carries a lot of experience in the telecom field. Mr. Mittal will give us an overview of ITU and 3GPP, and I do hope that he will talk about the wonderful achievement of TSDSI at ITU, the recent achievement. Over to you, Mr. Mittal.
Thank you, Bindu. And good afternoon, good morning, everybody. I am also not putting on my video because I think the bandwidth should be saved so that the slides and the speech are better. So I will start with my slides. So the subject is Introduction to GPP and ITU. In fact, both are very vast organizations and we can talk at length about them, but the time given is about 10 to 15 minutes. This was known, so I have kept it smaller, but some of the things which are not on the slide, I will try to take up verbally. So first about the 3GPP. This is called Third Generation Partnership Project. So it started with 3G, but even in the 5G era, it is called 3GPP. And there are, this is a kind of consortium or a loosely constructed organization which doesn't have a legal structure, but this is consists of organizational partners. I will show who are the partners in the next slide, but there are organizations like TSDSI and other standards bodies across the world. And the structure looks like this, that there is a project coordination group which consists of the representatives from the OPs. And there are three main technical study groups which are called RAN, TSG RAN, Radio Access Network, TSG CT, Core Network and Terminals, and SA, Service and System Aspects. So as the name suggests, the RAN is the radio part of the network, and CT is the core network and terminal part, and SA has the main job of defining the services output from this network and also how the architecture should look like, and also all the related aspects it deals. So if you see quickly the working groups, the RAN is the governing group for the RAN working groups, which are 1, 2, 3, 4, 5, and 6. There are 6 RAN working groups, each dealing with different aspects, which are written here. I will not read through them separately, but they cover the layer 1, layer 2, layer 3, radio performance, and testing aspects. And CT deals with the terminals and the interworking of the radio network with the core network and the external networks. And the services and system aspects, as I told you, it covers architecture and services, and also most important part, security, as well as the mission critical applications, which was added a couple of years or maybe 3 years back as main item, one of the important items, creating a working group called SA6. And in SA6, we have current chair of the SA6 is Mr. Suresh Cheturi, who is from Samsung India, and Samsung India is a TSDSI member. So there is a leadership position for TSDSI there. Now, the TSGs are, as we said, they are organized into working groups. TSGs meet once every quarter, which are called plenary meetings, but that time working groups are not in session. And working groups meet once or more per plenary cycle. In fact, some working groups meet almost 8 to 10 times a year, some less, but a lot of work is done. And kind of attendance, if you see, I have mostly attended RAN meetings. So RAN 1, if you sit, there may be about 400 people sitting, or 450 people sitting in one room and discussing papers. Similarly, other groups also, they have a lot of attendance. SA also is highly attended. And then CT. So there is a lot of interest and a lot of interaction takes place. We can't go into much detail that how they actually work because it's a quite a lengthy process, but it's quite interesting and quite challenging, to take papers there and get them accepted, get them incorporated. So those are the details which we can talk later. Then they have leaders, which are the chairs of these working groups and the RAN SG. They are elected for 2-year term and they can have maximum 2 terms from the same company. Overall planning and coordination, and as you already mentioned. Now, most important part is that individual members participate in TSG and WG. What happens that the operational partners like TSDSI, organizational partners like TSDSI and others, they have their member companies or organizations like academia. So they become individual members. Apart from becoming members of the TSDSI like organizations, they also have to become individual members to participate in the meetings of 3GPP. So these are the partners: ERIB from Japan, ATIS from US, CCSA China, ETSI Europe, TSDSI India, TTA from Korea, and TTC again from Japan. So these are the organizational partners, and each of these partners have their member companies and academia and other organizations who through them become individual members of 3GPP. And they also have in their structure market representation partners. They are the organizations which support 3GPP either in promoting the 3GPP activities and also providing market inputs to 3GPP, which can go into standards through the PCG, the Project Coordination Group. So these are some of the examples. From India, you can see CAI, Cellular Operators Association of India. Then we have organizations like ESOA, Satellite Operator Association, GCF, which is a certification organization, Global Certification Forum, which certifies 3GPP based products. Till now it has been doing the mobile instruments. Now it is going into the IoT also. Already gone into the IoT testing, IoT device testing. Now, briefly speaking, how it works. Now, 3GPP works, on face-to-face meetings. Of course, in COVID time, all their meetings for last almost since February onwards, their meetings have been converted into e-meetings. Then you have to bring contributions there, and normally consensus-based approach is adopted. And if there is no consensus, there is also a provision for voting, which is rarely adopted. Normally, people agree or disagree, and they may also withdraw their proposals or on negotiation modify their proposals. So consensus is the main buzzword, but if there is a requirement, then voting also can take place. The work, how the work happens, the proponents, they bring in proposals for technical study items where the report is generated, or work items where it contributes to already an item of standardization which is already adopted in 3GPP, that this is an item where we have to make standards. So it is split into number of work areas and work items are brought in. Study items, they provide inputs for further work, or they study whether some particular work is to be taken or not, advantages, disadvantages, and way forward. And the main way of functioning of 3GPP has been that they create releases which have fixed timelines and which are partially overlapping. Now, releases are basically a set of specifications which provide a standard which is much different than a previous release, which has much upgraded. If a release is not, before a release is granted, their specifications are periodically updated in the meetings depending on inputs, and new versions are released. But when new items and new standards, new areas of work are included, then it is decided to create a new release. And till now, release 16 releases have come. And to give an example, release 10 to release 14, mainly it covered 4G and 4G Advanced, the 4G Pro. And release 15 onwards, it is 5G. And only in July, 3rd July meeting, the TSG plenary cleared and frozen release 16, which is also the further upgrade of release 15 of 5G. And work is already going on release 17, which is slated for completion in June 21, but likely to be This schedule is likely to be, uh, postponed because of COVID-19 e-meetings taking place and the kind of output which was coming in the face-to-face meetings. The feeling of the meetings are that it is not giving sufficient time to complete the work. And work plan. So work plans are made for each release, which items will be completed at what time, and they are strictly monitored in the TSCs. And whenever they go for a release, the requirements, then architecture, then protocol. This is the sequence in which a release is planned, and the work goes on in TSDs around the work to WGs. WGs have a timeline to create work complete of these stages, and then release is finally frozen. And there are so many companies actively participating from in 3GPP work. Actually, from India, we have about 19 IMs, companies and academia who are participating in 3GPP as IMs, and more vertical industry who are not telecom industry on themselves, but they are becoming members like automotive industry because they are creating connected cars and there will be a complete intelligent transport system specifications which are in place and which are being upgraded. And there are similarly other verticals which will come in health and you name it, and they will come to put in their requirements as a part of standards. And the track record has been that when it started in 1998, it has continuously given releases starting from 3GPP, the 3G, UMTS, 4G, Volte, IMS, NB-IoT, 5G. So it's a continuous progress, and every release has been, it has taken time from 15 to 24 months, depending on the work and the output produced by the groups. And the timeline provided for release 17 beyond release 16 was 18 months, but we have to see how much time it takes. And our companies have been contributing to 3GPP. Recently, the NAVIC system of ISRO, which is a geopositioning system like GPS, that also was included based on the contributions made by ISRO and some of our members in 3GPP. It has become part of the 3GPP specs. So maybe by next year, even now some handsets have started putting NAVIC into their system, but by next year March you will find the phones will start having NAVIC at a wide scale. And there are other contributions also which were made, but we will talk about that more in the ITU part of it. So quickly coming to the ITU, this most of the people who are in telecom may be knowing it's the oldest standards organization in the world, created in 1865 and took its present shape after the World War II. It is based in Geneva, currently 193 member states, 800 entities and academic institutions, and it has 12 regional offices for regional coordination and promotion of telecom standards. It's a specialized agency of UN for ICTs, and it has mainly three sectors: radio communication sector, standardization sector, and development sector. So as the name suggests, radio communication is for global radio spectrum management and radio communication standardization. And ITUT does non-radio network standardization, but also covers parts of the radio network which are not directly radiating elements, but for example, core networks and their quality of service on the core and other parts. So it has standards on those parts. And the services aspects, services to be delivered from telecom networks. Numbering plans, allocation of numbering plans, etc. So many things which they, for proper interoperability, they define in the ITUT sector. ITU development D sector is for development. It is basically meant for assistance in extension of ICTs to all world's habitants, narrowing the digital divide. So its main role is basically to promote telecom development and have more focus on developing and less developed countries. And each of these sectors, they work on a 4-year development cycle. For 4 years, their business is fixed, and they complete that. And then after 4 years, their parent body meets. For example, ITUR parent body is Radio Assembly, which meets about every 4 years. ITUT has a WTSA, World Telecom Standardization Assembly, and D has WTDC, World Telecom Development Conference. So ITUD, we talked about it, what it does. It has two study groups. One is study group 1, enabling environment for development of telecom ICTs, and Study Group 2, ICT Services for Sustainable Development. So as the name suggests, these are the two main groups, and it creates reports and does a lot of promotion activities, assistance to developing or less developed countries. ITUT is a very big setup in terms of study groups which has and the range of subjects it covers. You see here, they are up to study group 20. There are actually 11 study groups. Other study groups have been created and disbanded over the course of time once their job was over, or they merged into other study groups which were created later. So if you see quickly, operational aspects, SD2, economic and policy issues, environment, broadband, protocol, performance, QoS, QoE, SD3, future networks with focus on IMD 2020. So this is the group currently working on the future technologies and has created focus groups also for working on different aspects, including AI and ML and IMT 2020, how the future networks will look like, what are the services which will come, what are the challenges will throw. So it is doing a lot of interesting work presently. And transport, access, and home. So all optical fiber networks and how to provide access to homes and how to provide the access network on fiber and other transport networks. And multimedia is the thing which is not only on wireless but also on landline and optical networks. Then security. Security is a horizontal which covers radio and non-radio networks. So it covers all aspects of security. Then IoT, smart cities and communities. This is a more recent, which was created around 2014 or 15, and in fact, it is closely working with M2m. You listen to Mr. Orindam about 1M2M. So some of these specifications of 1M2M have been adopted by SD20 as ITU specifications. We as TSDSI are currently member of SG15, and where we took support from them for creating our standard on CPRI front haul, which is TSDSI own standard. And ITUR is the radio communication sector. So it has also up to study group 7. There are actually 6. So spectrum management, radio propagation, satellite services, terrestrial services, and what we do in IMT today, the mobile services, this is actually done in study group 5, which has 4 working parties dealing in different parts. We will come to that in the next slides. And it has broadcasting service study group, so terrestrial broadcasting, sound and TV is dealt in this. And study group 7 is on science services. You can see a lot of things which as communication people we don't deal with them, but because they use different frequencies, so which are very close to telecommunication network frequencies, or so there's a lot of significance as far as telecom people are concerned for dealing with the frequency bands and seeing that we don't create interference to these science services. So ITUR study groups and this work has a lot of interesting things. Probably once we start participating, we come to know. So to go into more details about ITUR study group structure, so it is top body which decides its working methods and actual work what it will do, and decides the policies of radio communication sector is radio assembly. And then it has study groups, and we are members of study group 5, which has 4 working parties: 5A, 5B, 5C, and 5D. Each of these working parties are further subdivided into working groups and sub-working groups. So if we see the work on mobile systems is happening in WP5D, which meets about 3 to 4 times a year. It has 3 main working groups: general aspects, technology aspect, and spectrum aspects. And there are a number of sub-working groups which deal with different subjects of each of them. So now I will stay briefly on this slide and add something that what TSDSI has achieved by participating in ITU over the years, over the last 4 years, is that for the IMT 2020 or 5G, our study group had our IMs, some of the IMs, especially IIT Madras, IIT Hyderabad, and CIVIT, they had created certain specifications which we wanted to become part of 3GPP standard when they were working on 5G release 15. But somehow, because of the dynamics, what happens there, which cannot go into details right now because of paucity of time. So those things, they were not accepted, or whatever was accepted was in much diluted form. So, and also it is important to know that 3GPP standards, what they make, especially the radio interface standards, what they make, they feed into ITU, Study Group 5, to be adopted as international standards. So TSDSI IMs, they brought those specifications part, or those special features, which were actually add-ons to the existing 3GPP or release 15 3GPP specifications, to the study group networks in TSDSI. They were debated in the study groups, and then contributions were made in Working Party 5D. And there's a very detailed process for acceptance of any technology in ITU as a standard. So we only because of these specific features, we created our own 5G standard, which is based on 3GPP, but with additional features, which are aimed at larger coverage, especially in rural areas, without changing the cost, and reducing the cost of network deployment in rural areas by increasing the range, which can go up to 6 kilometers radius, and technology has capability to make it even 12 kilometers by enabling certain features in the system. And it is most of it is software driven changes in the system. So that has been the work which was going on in ITU for last 4 years, and finally in the meeting which ended on 9th July of WP5D, TSDSI technology has been accepted as one of the technology which will figure in ITU our recommendations on IMT 2020, which is also called 5G, as a specification. So this is a big achievement for Indian industry, academia, and the perseverance of everybody, and the whole TSDSI, and the collaboration which we did at the ITU level, which resulted into that. So we are on the international fora with our own technology, and we will keep on upgrading that. And one last thing about membership, how we can be, what membership are there in ITU. Member states is the original constitution of ITU, when only governments could become members. Then sector members came, which can be from industry, academia, or industry. Associate members are also from industry or something, but they can participate on one specific study group and pay fee for that, and only part in take a study group, ITUT or ITUR or ITUD. Academia members, their entry requirements are very less, but they don't have decision-making powers and voting rights. And there are certain exempted entities which have international work type of nature, and non-profit members and non-profit entity. They can, they are there in ITU. Academia, for example, if they become member, there will be a question naturally if they can become member directly, then why through TSDSI and all. It is very important to note that in fora like ITU, it is the collective strength or organization strength that things get through. An individual organization, if it proposes a proposal, the barriers to those things going through are very high. It takes a lot of collaboration and a lot of kind of managing the dynamics there, and having offline talks and carrying through the proposal. So only for gaining of knowledge, individual membership may be okay for academia, but when we are sector members or association members, then we carry more strength and more capability of negotiating and sailing through. Though of course that is also quite difficult. Thank you. So this was my presentation.
Thank you very much, Mr. Mittal, for giving the overview of ITU and 3GPP. And also, I'm sure the presentation would have given some ideas to the participating research scholars and participants on topics that they can contribute to at ITU and at 3GPP. So we look forward to the research scholars and faculty to engage with TSDSI, maybe through over email or by participating in our meetings, to explore how we can work together. And in fact, the next session is going to be all about the research work that the institutes are doing, the 5 participating institutes are doing, and how we can collaborate.